Start one.
Good morning, students. Once again, welcome to our online classes. Today, we are going to study about new chapter, Theory of Equations. From this chapter, we will get one 7-mark problem and one 2 marks problem in your public examination. So, the total weightage of this chapter is 9 marks. So, let us start today's class. In our class, we are going to study about nth degree polynomial, monic polynomial, roots of a polynomial equation, and the relation between the roots and the coefficients in an equation. In your 10th class, you have studied about polynomials and some of their properties. Now, let us recall them and also know some more new things. Okay, student? Now, what is nth degree polynomial? So, you know that a polynomial of degree n is nothing but if n is a non-negative integer and a0, a1, a2, so on, an are real or complex numbers and a0 not equal to 0, then an expression f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on an is called a polynomial in x of degree n. Here, the highest power of x is n, so it is called as a polynomial of degree n. And the quotient of this x power n, that is a0, is called the leading quotient of f of x, and an, that is the term which is not having x variable, is called constant of f of x. So here leading quotient, if leading quotient a0 is equal to 1, then what happens? The equation becomes, or the expression becomes, f of x is equal to x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on an. This expression is called monic polynomial. So monic polynomial means a polynomial with leading quotient is equal to 1, then it is called as monic polynomial. So one of the example of monic polynomial is x cube plus 3x square plus 4x plus 5. Here, the degree of this polynomial is 3 and the quotient of the highest power variable, that is x cube, is 1. So since the quotient of x cube is 1, it is called as monic polynomial. Now, we will deal with polynomial equations. If a polynomial expression f of x is equated to a constant value, then it becomes a polynomial equation. That is, if f of x is equal to 0, then we will call this as polynomial equation. So the nth degree polynomial equation is represented as f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on plus an is equal to 0. Now, let us see the topic of root or roots of a polynomial equation. So, consider the nth degree polynomial equation. So, already you learned about nth degree polynomial equation, that is f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2, so on an is equal to 0. Then a real or complex number alpha is said to be a zero of this polynomial equation if it satisfies the equation. That is, if f of alpha is equal to 0, then I can call this alpha, that is real or complex number, as the root of the equation f of x equal to 0. So substitution means in the place of x, I will replace alpha. Then I will get f of alpha, which is equal to a naught alpha power n plus a1 alpha power n minus 1 plus a2 alpha power n minus 2. So on an is equal to 0. So from this, we can note that if alpha is a root or 0 of the polynomial, then we can say that x minus alpha is a factor of that f of x. Okay, if alpha becomes a root, then x minus alpha becomes the factor of f of x. And see here, if alpha 1, alpha 2, alpha 3, so on alpha n are the n roots of the polynomial f of x, then we can express f of x as f of x is equal to x minus alpha 1 into x minus alpha 2 into x minus alpha 3, so on x minus alpha n. Students, once again see this equation. Whenever the roots of a polynomial expression or equation are given from the roots, we can build up the equation of polynomial. Here, since alpha 1 is a root of f of x, here x minus alpha 1 is the factor of f of x. Similarly, if alpha n is a root of f of x, x minus alpha n is a factor of f of x. So, if any alpha is a root of f of x, we can say that x minus alpha is a factor of f of x. Now, to know some more relationships between roots and coefficients of polynomial, let us consider nth degree polynomial. So what is nth degree polynomial? F of x is equal to a naught plus a1x plus a2x square, so on an minus 1 x power n minus 1 plus an x power n. Here an is not equal to 0. Since it is a nth degree polynomial, an will not be equal to 0. So in this case, if n is equal to 0, what happens? See the equation. If n is equal to 0, the value of f of x will be equal to a naught. So a naught is a term without x variable. So in this term, we cannot see x. So since x is not there, we can call this as constant term. And this polynomial is called a constant polynomial. And constant polynomial will have no root. Since x is not there, it has no roots. And if n is equal to 1, what happens? So put n equal to 1 means 0 and 1. Then f of x will become a naught plus a1x. Children, see this expression? In which form it is? It is in a linear form. So a naught plus a1x. Since the highest power of x is 1, it is called linear polynomial and it has only one root. So for our convenience, we will consider that root as alpha in some cases. So next, if n is equal to 2, what happens? If n is equal to 2, f of x is equal to a naught plus a1x plus a2x square. Can you remember this equation? In the last class, we have studied about quadratic polynomial and quadratic expressions and equations. So this is in the form of quadratic equation, that is a naught plus a1x plus a2x square, and this is called a quadratic polynomial. And how many roots a quadratic polynomial will have? Yes, 2 roots. Since the highest power is 2, so the polynomial will have 2 real or complex roots. So every quadratic polynomial will have 2 real or complex roots. So for our convenience, we will consider these roots as alpha and beta. And if n is equal to 3, f of x will become a0 plus a1x plus a2x square plus a3x cube, and it is called as cubic polynomial. Since the highest power of x, n value is equal to 3, it is nth degree, so it is called third degree polynomial. So we can name it as cubic polynomial. And every cubic polynomial will have 3 roots. And for our convenience, we will consider them as alpha, beta, and gamma. And if n is equal to 4, what happens? If n is equal to 4, the polynomial becomes f of x is equal to a0 plus a1x plus a2x square plus a3x cube plus a4x power 4. Here again, the condition is a4 not equal to 0. Since the highest power of the polynomial is 4, it is called as biquadratic polynomial. The polynomial of degree 4 is called as biquadratic polynomial, and it has 4 roots, and they are alpha, beta, gamma, and delta. So children, in our chapter theory of equations, we deal about the polynomials of degree 4, that is biquadratic polynomials and biquadratic equations. So let us know the information till now. So if n equal to 5, it is called fifth degree polynomial. If n is equal to 6, it is called sixth degree polynomial, and so on. So if n is equal to n, it is called nth degree polynomial. So what you have observed, only for constant polynomial, we have no roots, but for every polynomial, we have at least one root. So we can conclude that for every non-constant polynomial, it has at least one root. Now, let us derive a relationship between roots and coefficients in an equation. So in your earlier class of chapter quadratic expression, you have derived the relationship between roots and coefficients of the equation, but that is for quadratic, that is second degree polynomial. Now we will see the rest of the polynomial equations. So let us consider the nth degree polynomial equation. That is f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n plus so on plus equal to 0. Here a0 0, and this is an nth polynomial equation. So you know that as now let us put as alpha 1, alpha 2, so on alpha n. Then the relation between this quotient and root can be derived as minus a1 by n. So you observe here that is root of x power n minus 1 by coefficient of x power n. So alpha 3 and so on alpha n. And next one, a2 by a0, which is equal to s2, which can be written as summation of alpha I into alpha j, where 1 less than or equal to I, less than or less than j, less than or equal to n. And next, and next one, so observe the next one, A3 minus A3 by A0, which is equal to S3, which is equal to summation of alpha I into alpha j into alpha k, where ij lies between 1 and the relation between I and k is I less than j less than k. Here we are taking summation of roots which are 3 at a time. So this is the value of S3. Next, similarly, we can conclude for general term, that is minus 1 to the power of n, an by n is equal to Sn, that is equal to alpha 1 into alpha 2, so on alpha n. It is the product of roots, that is nth roots. So note here we are doing the relation for general n value. Okay, for general n values we have derived. Now we will apply this concept to n equal to 2, n equal to 3 and up to 4, that is till biquadratic. So we recall the quadratic equation. In quadratic equation, that is nothing but degree polynomial equation, we said it has at most 2 real roots, 2 real or complex roots, and we consider it as alpha and beta. And we also know that the sum of the roots equal to minus b by a, and alpha product of the equal to c by a. In our previous classes, we have derived the relationship that is equal to minus b by a and alpha to c by a. Now observe the concept. Alpha plus beta and is equal to minus coefficient of x by coefficient of x square and product of the roots, that is Sn. See here, if n is equal to 2, I will get this as S2 and I will get minus 1 to the power of 2, that is positive constant term by a. So observe this condition for n equal to 3. So for n equal to 3, we get a cubic equation, that is x cube plus a1x square plus a2x plus a3 equal to 0. Here S1, that is the sum of the roots. Here we are considering the roots as alpha, beta and gamma. So the sum of the roots S1 is equal to alpha plus beta plus gamma, which is equal to minus a1 by a0. So children, observe here, what is the value of leading coefficient a0 here? 1. So since the value of a0 is equal to 1, I can call this as monic polynomial of degree 3. And here, so minus a1 by a0, since a0 is 1, I am taking the value s1 as minus a1. And S2, that is sum of the product of the roots taken 2 at a time. So once again listen this concept. S2 is nothing but sum of the product of the roots taken 2 at a time. So the possible products we can find out from alpha, beta, gamma is alpha, beta plus beta, gamma plus gamma, alpha. And this value will be equal to a2, that is coefficient of x. And S3, that is product of the roots taken 3 at a time. So we have only 3 roots. So we have only one term, that is alpha into beta into gamma, which is equal to minus A3, that is minus of constant. Now for n equal to 4, we get a biquadratic equation x power 4 plus a1 x cube plus a2 x square plus a3x plus a4 equal to 0. Here again, the leading coefficient a0 value, I am taking it as 1. So then I will get alpha, beta, gamma and delta as the 4 roots of this equation. And what will be the value of S1? S1 is the sum of the roots, that is alpha plus beta plus gamma plus delta, and the value will be equal to minus of x cube quotient by quotient of x power 4, that is minus a1. So S1 value will be equal to minus a1 for monic polynomial. And what will be the S2 value? S2 is a sum of the product of the roots taken 2 at a time. So S2 is the sum of the product of the roots taken 2 at a time. So we have 4 roots, that is alpha, beta, gamma and delta. So find out the product of 2 roots, that is all possible conditions. See here, alpha into beta plus alpha into gamma plus alpha into delta plus beta into gamma plus beta into delta and last plus gamma into delta. So these are the all possible multiples of products taken, multiples of roots taken 2 at a time. And what will be the value of S2? It will be A2. And next S3, that is S3 is the sum of the product of the roots taken 3 at a time. So the possible terms I can get in this condition are alpha beta gamma plus alpha gamma delta plus alpha beta delta plus beta gamma delta. You once again, you also check whether you are getting these combination or not. Okay. So S3 value will be equal to minus A3. So minus A3 means minus 1 to the power of 3 A3. So since minus 1 to the power of 3 is negative, so S3 value will be equal to minus A3. But we have nth degree and 4 roots, we will get S4 also. So what will be the S4 value? It is the product of 4 roots taken at a time. That is alpha, beta, gamma, delta. So which is equal to A4. So by using this relation of between the roots and the coefficients of the polynomial equations, we will find out some of the problems and solve them. Okay. Problem 1. If 1, 2, 3 and 4 are the roots of the are the roots of the biquadratic equation x power 4 plus ax cube plus bx square plus cx plus d is equal to 0, then find the values of a, b, c and d. Here a, b, c and d are the coefficients of the equation. So my work is to find out the value of a, b, c and d. So what you know, if we get or if roots of the equation are given, we can reform that equation as x minus alpha 1 into x minus alpha 2 into x minus alpha 3 and x minus alpha 4. So see here, given that the roots of the polynomial equations are 1, 2, 3 and 4, then the given biquadratic polynomial equation can be written as x minus 1 into x minus 2 into x minus 3 into x minus 4, which is equal to 0. So by multiplying this x minus 1 into x minus 2 x minus 3 into x minus 5 and simplifying, we get the value as x power 4 minus 10x cube plus 35x square minus 50x plus 24 equal to 0. See here, we are having two equations. We are equating two equations here. So when two equations will be equal, their coefficients will be equal. So on equating the coefficients of like powers of x, we obtain. See here, what is the coefficient of x on the LHS side? A is equal to minus 10. Similarly, coefficient of x square, b is equal to plus 35. And what is the coefficient of x? C is equal to minus 50. Constant b is equal to 24. So when are given, we can form the coordinate equation that roots, and we have to find out the value of A, B, C, and D. Now let us take one more example problem. Form a polynomial equation of the lowest degree with roots 1 plus or minus 2i, 4, 2. How many roots have been given? Unstrict roots. There are 4 roots. Here 1 plus 2i is to find out the polynomial equation with this 4 roots. So for my convenient, I am taking roots as I'm naming the roots. Okay. So let alpha is equal to 1 plus 2i, comma, beta is equal to 1 minus 2i, gamma is equal to 4, and delta is equal to 2. So from this information, that is the polynomial equation with roots alpha, beta, gamma, and delta, I can write a polynomial equation with lowest degree as x minus alpha into x minus beta into x minus gamma into x minus delta is equal to 0. Now substitute the values of alpha, beta, gamma, and delta. Then I will get x minus alpha values here 1 plus 2i into x minus 1 minus 2i into x minus 4 into x minus 2 is equal to 0. The bracket, what I will get? X minus 1, so minus of plus minus. So x minus 1 minus 2i, next bracket, x minus 1 minus into minus plus 2i, and later x minus 4 into x minus 2 is equal to 0. So see the terms in the bracket, they are in the form of a minus b into a. So what is the formula of a minus b into a plus b? Yes, a square minus b square. So substituting the value a as x minus 1 and b as 2i, I will get x minus 1 whole square minus 2i whole square into, now by multiplying x minus 4 into x minus 2, I will get x square minus 4x minus 2x plus 8 is equal to 0. In the next step, I will get x minus 1 whole square, that is x square minus 2x plus 4 minus 2a whole square can be written as 4. Since here I square value will be minus 1. Minus 1 into minus plus 2 square, which will be equal to 4. And by simplifying this term, that is x square minus 6x plus 8 is equal to 0. So again by multiplying these two equations, what I will get? X square minus 2x plus 5 into x square minus 6x plus 8 is equal to 0. So x square into x square, I will get a biquadratic equation. So it will be x power 4 minus 8x cube plus 25x square minus 46x plus 40 equal to 0. Therefore, x power 4 minus 8x cube plus 25x square minus 46x plus 40 equal to 0 is the is the biquadratic equation with roots 1 plus or minus 2i, 4 and 2. Okay. Next problem. So see the next problem, children. If alpha, gamma, beta, gamma are the roots of x cube plus ax square plus bx plus c is equal to 0, then find sum of alpha square into beta plus summation of alpha beta square. So what have given? First of all, check what have been given. So they have given that alpha, beta, gamma are the roots of this cubic equation x cube plus x square plus dx plus c equal to 0. Okay. So now by comparing this cubic equation with the standard cubic equation, that is x cube plus a1 x square plus a2 x plus a3 equal to 0, I will get a1 is equal to, that is quotient of square is equal to a, and a2, that is quotient of x is equal to b, and a3, that is constant term, is equal to c. And also in the question, it has given that alpha, beta, and gamma are the roots of the above equation. So from the known condition, that is S1, that is S1 value will be equal to minus A1. So what is S1? S1 will be the sum of the roots, that is alpha plus beta plus gamma, which is equal to minus A1. What is the value of A1 we have? Yes, A. So the value of A1 is A. By substituting it, I will get alpha plus beta plus gamma is equal to minus A. So take it as equation 1. And next, what is the value of S2? S2 will be equal to A2. Now what is S2? S2 is the sum of the product of the roots taken 2 at a time. That beta plus beta gamma plus gamma alpha. And the value is equal to B. Take it as equation 2. Now consider at last S3. S3 will be equal to minus A3, and S3 is the product of 3 roots, that is alpha, beta, gamma, which is equal to minus C. Take it as equation 3. Now remember this equation 1, 2 and 3. Okay. Now we will solve to find out that condition. So in 1 and 2, we get alpha plus beta plus gamma into alpha beta plus beta gamma plus gamma alpha is equal to minus AB. Now again by multiplying this, see here, I am multiplying first by alpha. Then what I will get? Alpha into alpha beta, that is alpha square beta plus alpha beta gamma plus gamma alpha square. So multiplication with alpha has been completed. Now I am multiplying with beta. So plus alpha beta square plus beta square gamma plus alpha beta gamma. Again by beta also I completed. So now multiply with gamma. I will get plus alpha beta gamma plus beta gamma square plus gamma square alpha, which is equal to minus AB. So children, observe here the terms alpha square beta, beta square gamma, and gamma square alpha. I'm taking in one bracket. So alpha square beta plus beta square gamma plus gamma square alpha whole plus, again I'm taking these terms in one bracket, that is alpha beta square plus beta gamma square plus gamma alpha square. What have been left here? Alpha beta gamma plus alpha beta gamma plus alpha beta gamma. So adding these 3, I will get 3 alpha beta gamma, which is equal to minus AB. See, this can be written as summation of alpha square beta. So children, what is the meaning of summation? In the summation, we will take the term beta after alpha and the term alpha after beta. Alpha, beta, gamma will be in rotation form. So this is written as summation of alpha square beta, and this term can be written as summation of alpha beta square. minus 3c. So since the value of alpha, beta, gamma is minus c, by substitution I will get minus 3c is equal to minus ab. By sending minus 3c to right side, I will get summation of alpha square beta plus summation of alpha beta square is equal to 3c minus ab. So in the question, they have asked to find out the value of summation of alpha square beta plus summation of alpha beta square. So I got the value as 3c minus ab. Is it clear? Now consider next problem. If 1 comma 1 comma alpha are the roots of x cube minus 6x square plus 9 minus 4 is equal to 0, then find alpha. So here they have given 3 of the roots, but this one is unknown. So my work is this root value. So given the root of the cubic equation is 1 comma 1 and alpha. So for my convenience, I'm taking the value of standard cubic polynomial equation. So by comparing the given polynomial equation with standard cubic polynomial equation, which is mnemonic, that is if leading quotient is 1, then I will get the quotient of x square, a1 equal to minus 6, a2 is equal to 9, and a3 equal to minus 4. Then since S1 is equal to sum of the roots, that is by formula S1 value is sum of the roots equal to minus A1. So by substituting the concept, sum of the root, that is 1 plus alpha is equal to minus A1, that is minus of minus 6. So then I will get 2 plus alpha to 6. That implies alpha equal to 6 minus 2. Therefore, the value of alpha is 4. So 1 comma 1 and 4 are the roots of the given cubic polynomial equation. Now consider the next problem. Given 1 minus 2 and 3 are the roots of cubic polynomial equation x cube minus 2x square plus ax plus 6 equal to 0. Then find the value of a. So for my convenience, I am taking the value of the roots as alpha, beta, and gamma. By comparing the above equation with the standard cubic polynomial, that is x cube plus a1x square plus a2x plus a3 equal to 0, we get a1 is equal to minus 2, a2 is equal to a, and a3 equal to 6. To find out a value, that is value. So in the relation quotients and roots, the term is S2. So consider what is S2? The sum of product at a time, that is S2 is equal to alpha beta plus beta gamma plus alpha gamma is equal to A2. Now substitute the values of alpha, beta, gamma. That is 1 into minus 2 plus minus 2 into 3 plus 1 into 3 is equal to, what is the A2 here? A. So that implies by solving the values, I will get minus 2 minus 6 plus 3 is equal to A. Therefore, A value will be equal to minus 5. So whenever roots have been given, I can find the unknown coefficients of the equation. And in the previous problem, you have seen that if coefficients of the problem or equation have been given, we can find the roots. Is it clear? And that is the relation between roots and coefficients of the polynomial. Now see here, if alpha, beta, and 1 are the roots of polynomial equation x cube minus 2x square minus 5x plus 6 equal to 0. Then find alpha and beta. So here I am taking the equation and see here S1, that is sum of the roots alpha plus beta plus 1 is equal to A1. What is the value of A1 here? Minus A1, 2. So by taking 1 to right side, I will get alpha plus beta is equal to 1. And what is the product of the roots? Alpha into beta into 1. That is alpha beta is equal to minus 6. So we know that alpha minus beta whole square, that is a minus b whole square, is equal to a plus b whole square minus 4ab. So in the place of a, I am taking alpha, and in the place of b, I am taking beta. So by substituting the values of alpha plus beta and alpha beta, I will get 1 square minus 4 into minus 6, that is plus 24, which is equal to 25. This is the value of alpha minus beta whole square. From this, I can derive alpha minus beta value as 5. So already I got alpha plus beta is equal to 1. Sorry, it is 1. And alpha minus beta is equal to 5. So by adding both of them, I will get 2 alpha is equal to 6. That implies alpha equal to 3. And what is the relation between alpha and beta? Alpha plus beta is equal to 1 here. So by substituting the value of alpha, I will get beta is equal to 1 minus alpha, that is 1 minus 3, which is equal to minus 2. Therefore, the value of alpha is equal to 3 and the value of beta is equal to minus 2. Children, this is the most important problem. Okay, see this problem. If alpha, beta, gamma are the roots of ax plus b equal to 0, prove that sum of alpha minus beta into alpha minus gamma is equal to 9a. So, given alpha, beta, gamma are the roots of x cube minus ax plus b equal to 0. By comparing this equation with the standard equation, value of a1 here, a1 is the quotient of x. Since the equation does not have x square term, then the quotient of a1 x square can be written as 0. And a2, that is the quotient of x, here is minus 3a, and a3, that is b. Now I am taking the value of s1. S1 is the sum of the roots, which is equal to a1. A1 is equal to 0. Then I got alpha plus beta plus gamma is equal to 0. Next, S2, that is alpha beta plus beta gamma plus gamma alpha is equal to A2, that is minus 3A. And S is alpha beta gamma is equal to minus A3, that is minus B. Now consider which we want to find out, that is summation of alpha minus beta into alpha minus gamma. So multiply the two products, alpha square minus alpha gamma plus beta, that is equal to, see here, and alpha common from second and third term, then I will get alpha square minus alpha into beta plus gamma plus beta gamma. So see here, beta plus gamma. What is the value of beta plus gamma? From this equation, I can write beta plus gamma is equal to minus alpha. So sending alpha to right side, beta plus gamma is equal to minus alpha. So substitute that value, I will get alpha square minus alpha into minus alpha plus beta square. So it is into, since 2 is a real term, I can take common. So 2 into summation of alpha square plus summation of beta gamma. So summation of alpha square can be opened as alpha square plus beta square plus gamma square.
plus opening this beta gamma, I will get beta gamma plus gamma alpha plus alpha beta. So this is in the form of a square plus b square plus c square. So by using the formula a plus b whole square minus 2 ab plus bc plus ca, I will get this condition. So open this brackets, 2 into alpha plus beta plus gamma whole square minus 4 into the term plus the same term. Okay. So minus 4 into the term plus term means minus 4 plus 1, I will get minus 3. And what is the value of alpha plus beta plus gamma? It is 0. And the value of alpha beta plus beta gamma plus gamma alpha is minus 3a. So by solving, I will get 9a. So the value of summation alpha minus beta into alpha minus gamma is equal to 9a. Okay. Children, take today's homework. So we will check some more important concept in our next class. Okay.